Here are some more formal steps to graph a rational function. First off, we know our vertical asymptote occurs anytime the denominator is 0. Okay? So anytime you have a denominator 0, you're going to have a vertical asymptote. Now, you're going to have a horizontal asymptote if the degree of the numerator is less than the degree of the denominator. You're going to have a horizontal asymptote going through 0. Why is that? Because really, I am taking something divided by a really, really big number, and that gives us 0. It goes towards 0 because 1 divided by a really, really big number is 0. Now, if your degrees are the same, then we just look at the leading coefficients and divide them out. That's how we did it on the first problem. And if the degree of the numerator is bigger than the degree of the denominator, we don't have a horizontal asymptote. We have what's called the slant asymptote. We'll talk about those when we come across that. So I'm going to chunk this learning down to a different set. So to graph a rational function, here's what you're going to do. You're going to find the domain. So in other words, that's going to be your x-intercept. That's going to be your vertical asymptote. You're going to do your asymptotes for horizontal asymptotes. You're going to plot any x or y intercepts if they exist, and then plot at least one point in your test region to determine by x-intercepts or vertical asymptote. Explain that in a second. Okay, so we're going to pick a test point, in other words. So here's what we're going to do. I notice on this graph, on example 3, I have a vertical asymptote at x equals -3. So what I'm going to do is on my graph, and we pull it up here so you can see it, I'm going to draw a vertical asymptote going through -3. And blow up my graph a tad here so you can see it a little bit nicer. So I got 1, 2, 3. So here's my vertical asymptote. Then what I'm going to do is I'm going to look at my horizontal asymptote. Notice the degree of my numerator is 0. And the degree of my denominator is 1. So my degree of my denominator is bigger. Anytime it's bigger, we have a horizontal asymptote going through 0. So in other words, you have no x-intercepts because it's never going to cross. Now, if you have, that's not quite true because if you have 2 vertical asymptotes, that would be different, but we don't have that in this case. Now, let's look at our y-intercept. Our y-intercept occurs when x is 0. So my y-intercept occurs when I got 6 over 0 plus 3, or 6 over 3, which is 2. So I'm going to have y-intercept at 1, 2. Now, if I look at the way my graph is going, I can see, since I have a y-intercept of 2, and I have a horizontal going towards the right is going to be approaching 0, and then I'll probably do the same thing on the left. Now, you can't quite know that for sure, so this is what the last step was. Let's pick a couple test points in here. So for example, let's make a table for x and make a table for 6 over x plus 3, or y. I already picked my y-intercept, or I already picked my y-intercept, which was when x equals -3. So let's pick or when x equals 0, y is 2, right? Because that's what I did. So now let's pick a number, either to the left or to the right of my y-intercept. Really, you want to do is you want to pick numbers to the left and to the right of your vertical asymptote so you get kind of an idea of where they're at. So I know I've got a vertical asymptote going through -3, so let's pick -4. If I put -4 in for x, I got 6 over -4 plus 3. Well, that's 6 over -1, so I'm at -6. So when I'm to the left 4, 1, 2, 3, 4, I'm down at 6. 1, 2, 3, 4, 5, 6. And you can see that's the direction my graph is going.